And so, welcome to our new series of talks with the Center for Digital Humanities and Arts. So today, Alexander Peter Pfaff, lecturer in German, is going to talk to us about how many ways you can say it on measuring language diversity with digital methods. So, Alexander, you're welcome.
Thank you very much, and thanks you could make it to my talk. I will talk about one of my projects. I call it Patternization, well, yes, get into it. But maybe before that, I thought I'd start better with motivating why I am even here in the Digital Humanities. So I assume, or actually I don't know who, in what disciplines you're working, right? But I suppose somewhere in the humanities. So most of you will probably have heard of the so-called 7 liberal arts, right? The curriculum in the Middle Ages emerging from antiquity, of the curriculum of education of the free man back then, containing or having the disciplines like grammar, rhetoric, astronomy, music, etc., etc. And they are usually divided into 2 classes: the trivium, the three-way, and the quadrivium, where the trivium are the language disciplines or the linguistic disciplines, and the quadrivium are the mathematical disciplines. And those 2 classes are traditionally associated with humanities on the one hand and sciences on the other hand. So since I'm a linguist, I have already motivated 50% of why I'm here today, because I am a linguist, right? So I am a humanist in that respect. But of course, linguistics is a bit more complex, and I would just like to give you an overview. This is very broad. As I just said, linguistics has one foot in the humanities already by tradition, but it's a bit more complicated, because you could also argue that linguistics is a formal science like mathematics, computational science, and logic, especially formal syntax, formal semantics. We use methods that are essentially in semantics, for instance. Most of it is predicate calculus or predicate logic, propositional logic, lambda calculus. These are methods that come from logic and from mathematics. So it is actually very, very formal. To that extent, we are part of the formal science. But usually every textbook on linguistics will tell you that linguistics is a cognitive science, right? Having to do with the fact that human language is a product of the human brain. So we are also part of the brain sciences. And then there is another angle to the right, namely corpus linguistics. Corpus linguistics is not very far from data science, and maybe you know a bit about data science. It has been called the sexiest discipline in the 21st century, although the label is itself a bit confusing or a misnomer, because every empirical science is data science, pretty much. But nonetheless, the idea is here that we have electronically stored text, or collection of text that are enriched with features or attributes that can be processed by a computer, right? And we can use search engines to go through a corpus and use statistical methods, pretty much what people do in data science, even though the questions may be a bit different. So to that extent, actually you could argue that corpus linguistics is inherently an instance of, digital humanities, right? And this would motivate most of why I'm here today. But there is a bit more than just corpus linguistics. Here I enumerate the digital components. Like obviously, like what is essential for what I'm doing, what I've been doing, is the availability of annotated text corpora. This is the corpus linguistics component. There will be, I'll try to keep the mathematics to a minimum, but I will have to say a bit about mathematics, unfortunately. And then, of course, Python programming, and this is the most important ingredient for me, because what I'm going to show you or talk to about is my very own project. So the software I'm using, I developed myself. So this was for me a personal moment, that was very important. So I will focus on that a bit. As for the history, where I started, at a postdoc project in Oslo a couple of years ago, which was called Constraints on Syntactic Variation, Noun Phrases in Early Germanic Languages, I started programming, right? My task was, on the one hand, to design a database, or actually the annotation scheme for a database, and in collaboration with the Språkbanken in Göteborg, like in Sweden, who took care of the technicalities, the implementation and infrastructure, we developed a database of noun phrases in Old Germanic languages. The title or the name is MPEGL, which is an acronym for noun phrases in early Germanic languages. Here, by the way, this is, where's the mouse? Here, there's a link to the, here, this is a link to the database in case you want to check it out. Go there. Now, the next thing is, of course, my question that I would like to address a bit today is how to best comply with the project title, right? Syntactic variation and constraints on syntactic variation. I will say a bit more about that in a moment. One output, apart from the database itself, was our edited volume. It's open access, so you can actually go there, here. This is the link where you can access this. A lot of interesting stuff about noun phrases in Old Germanic languages, but in particular the first two chapters. You can download it chapter-wise as well. The first one is about the database as such, and the second chapter is about what I'm talking today, patternization, the method and the program. So, maybe since I don't know exactly like what disciplines you're working in, maybe not all of you are linguists. So maybe a few words about the main ingredients, what even is a noun phrase. I suppose you are at least familiar with the main traditional word classes and parts of speech, like nouns and verbs and prepositions and adjectives. Well, a noun phrase is a somewhat larger syntactic unit that has a noun as its core component, or sometimes a pronoun, right? So John or everything would be a noun phrase. But a noun phrase can be a bit bigger. It can, in fact, be quite a bit bigger. Like you can have adjectives and numerals and demonstratives and relative clauses, like all those three black horses with a yellow stripe on their nose that are standing over there, whatnot, would be one noun phrase. And you can test it actually like simply by checking, okay, where could it occur? Well, it could occur as the subject, for instance, or the object. In a sentence here, every blank here would be a possible occurrence for a noun phrase. So that's pretty much it. Syntactic variation, what is syntactic variation? Well, there's actually quite a lot to say about syntactic variation, but for today I will focus on the aspect word order variation, right? In which order can words occur, or do they occur? No. So this is an illustration how our database looks like, or the kind of information that is stored in our database. You can see we have meta information like, okay, this entry, from which language is it taken, then some information about where you can find it in the source corpus. Maybe I should mention that we used some existing annotated corpora to create our own database, because they already had some annotation that we could use. It's more convenient that way. This Icelandic example, for instance, is from IcePack, the annotated historical Icelandic corpus. There's some information about gender and number, etc. The syntactic function. So here in this case it is a predicate of a copular verb. He was a promising man and popular. And what you can see here, this is the most, which one is best with the mouse? The most important, the segmentation field here, because you can see these squared brackets. Those are the units that occur per entry. And what you see as a subscript, this would be the lemma, right? The base form of every single entry. And below, at annotation, you can see for every entry a number of features. And in the first column, these are the category labels. This is the most important ingredient that I would like to talk about today. Then there are also some semantic and morphological features. they are also incredibly useful and cool, but I will not talk about those here today. Mostly I will be concerned with the category labels, right? I mean, this here essentially means adjective, noun, coordination, and adjective. That's pretty much it, right? I don't want to go too much into linguistic details. Now, they did a pilot study. This was before I joined the project. Looked at some old Germanic languages, Old English, Gothic, Old Icelandic, Old High German, Old Saxon, and examined the relative position of certain modifiers. Modifiers like adjectives, possessive pronouns, numerals, etc., in relation to the noun. So pre-nominal, post-nominal, right? Very simple. So we have adjective noun versus noun adjective, numeral noun versus noun numeral, etc., etc. Now this is obviously a very useful point of departure, and of course this is what people often do and usually do, but it has its limitation. If you really want to say a bit more about the syntactic variation, well, that has its limitations, right, to this kind of representation. And I was thinking, okay, is there a way to address this issue a bit more, a bit better? My question was, is there a way to put numbers on syntactic diversity, on syntactic variation? And yes, there is. It's patternization. This is my project. Here you can see a link. This is to my GitHub page where you can actually find the package, the Python script and the databases, and test a bit for yourself. Now, patternization, obviously, like it has as a component the noun pattern. And what is a pattern? It's actually very, very simple. As a pattern, I define simply a sequence of category labels. Right? Here, in this case, we would have demonstrative, numeral, adjective, noun. And this is a, well, you can think of it as a search template or as a descriptive template. And there are many, many possible cases that fit that description. Here I've taken some modern English examples. These 2 big horses, those 5 cute penguins, etc., 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 right? They all satisfy the same description. They are all instances of the same pattern, right? That is, I hope, very straightforward. Now, of course, there are also patterns that would not be grammatical in modern English, but modern English is very boring in that respect, or very rigid. It doesn't have the flexibility as older stages of the language had. Here took as an example adjective, noun, possessive, prepositional phrase, right? You don't find it in modern English, but maybe in Old English. Actually, I don't know, it's possible, or Old Icelandic. Anyway, the takeaway lesson is that the pattern is simply an abstract template of category labels, right? We are not interested which concrete word occurs there, but simply the category label. And also, very obviously, for every pattern, we could have thousands of instances that fit that description. Right? So a pattern is it's an abstraction over concrete occurrences of noun phrases, right? That is hopefully clear at that stage. Now, the idea is that you could have, I don't know, these are just a few examples of what patterns could look like, right? Those are sequences of category labels. Adjective noun is a pattern, noun adjective is another pattern. Adjective noun would be a distinct pattern at this stage at least, right? Every different sequence of category labels is a different pattern. Now this is just to give you a brief overview over the actual contents of our database. As you can see, Old High German and Old Swedish, we have fewer than 1,000 annotated examples, so they will be largely ignored in the discussion here. In fact, it will mostly focus on Old Icelandic, but occasionally also mention Old English and Old Saxon. So on the top row, you can see here, these are the annotated, where is it? Here, in this row, how many noun phrases do we actually have? How many categories or category labels are used in that particular language or for those texts that we have, and how many patterns, according to the classification I just showed you, can we classify these noun phrases altogether. And of course, based on that, you can do some very simple statistics. Remember that my goal is to put numbers on syntactic diversity or syntactic variation. And one very first thing to do would be like a so-called type token ratio, how many patterns per noun phrases. And we would get the numbers you see in this top table over there. Now, something is not exactly right because it would suggest that Icelandic is relatively low. It's almost close to English, which cannot be true because Icelandic is much cooler than that and much more diverse. Obviously, this has to do with the numbers of annotated noun phrases in the database, right? Because think about it this way. You start annotating your very first noun phrase. There is a noun phrase count, and of course, it has a certain pattern. So you would have one pattern per one noun phrase. This is a score of 100%, maximal diversity. But as you keep annotating, the same pattern will be instantiated more and more often, right? Especially the common patterns, and at some point the ratio gets diluted. And since we have different numbers of noun phrases in the databases, we have different ratios. They are not exactly faithful. Now this would simply be a very simple statistic thing that we should not concern us with here today, but since I developed a method, I would like to mention it a bit. The idea is to get a better representation, we don't take the overall count of noun phrases, but let's say patterns per 1,000 noun phrases, right? So the idea is we take 1,000 randomly selected noun phrases of a database and count how many patterns there are. Let's say 200, then we have 200 per 1,000, right? But next time we do it, we may have 150 patterns per 1,000. So this is a bit, due to the randomness, right, could be a bit quite off. But the idea is if you repeat the procedure sufficiently often, then you will get numbers that converge at some point and give you a much more faithful representation. And as I said, I implemented this via a function in my program that does exactly that. And then we get these numbers which look quite a bit different and a bit more representative. And then, as you can see, Icelandic is on top, right, as expected. Now, this is a very simple mathematical procedure, not very profound, but still it's something, well, it's a point of departure. The next one is a bit more interesting. I was, for a different project, I was looking at possessive pronouns and adjectives in Old Icelandic, and at some point I felt like, wait a second, I have seen this example before. And I looked back into my collection of noun phrases and turned out, well, no, it's actually not the same. But the reason why I would think that is because the same adjective and the same noun and also the same possessive pronoun is involved, the reflexive possessive pronoun. The only difference is that the ordering is slightly different. As you can see here, we have possessive adjective noun, we have adjective noun possessive, etc., etc. So, right, those are 5 different constellations, 5 different orderings. Now, this is really what we mean by syntactic variation, by word order variation, and that's kind of what I'm interested in. So, what more could we say about that? Well, for one thing, we have 3 distinct items. Well, 3, in this case, it's accidentally the same noun and the same adjective, but we think a bit more abstractly, so we have 3 times the same category labels. Noun, adjective, possessive, right? So 3 distinct items. How many possible orderings could we even have? Well, that's a combinatorial problem. It's 3 factorial. 3 times 2 times 1, that's 6. We have 5 out of 6. Now, what to do with that? Well, let's turn into a measurement. And I call this combinatorial flexibility. Think of it this way. You enumerate all the possible orderings you could get here, like in this column here. This is the combination. These are the labels that you have, and these are the possible orderings that you get. And then you simply check, okay, does it occur in our database or not? You can give it a feature like plus minus attested, or simply a Boolean, true or false, right? And then you can count the true values, and you have a score 5 out of 6, right? Combinatorial flexibility 5 out of 6. Okay? That should be relatively straightforward. Now, what more? Okay, we have here 3 specific categories, and obviously the database is a bit bigger, and we would like to know a bit more about it. Well, unfortunately, we have to take a detour into mathematics, into basic combinatorics. Actually, two notions I would like to illustrate a bit more closely, namely permutations and combinations. Now, permutations, I just showed you, these are reorderings of the same items, and they can be calculated, or the number of those can be calculated via the factorial, which looks like a, well, which is an exclamation mark. This tells you how many different orderings of a given number of items you can get. Now, combination is slightly different. It asks in how many different ways can we combine three k items. To illustrate this, let's assume we have, just as a point of departure, we have a set A, B, C, D, E, F, and F, right? Whatever they are, just 6 distinct items. And we wonder how many three-way combinations do we get. That means how often can we take 3 items of that set and combine them so that we have 3 or respectively different sets. Let's skip the formula, but the formula tells us we get 20 distinct combinations, right? And these are listed here. The combinations are sets, and as you may know, a set does not have any inherent ordering. It's defined by membership, which items are contained in the set. So here we have ACB, which is the same as ABC, which is the same as BAC, etc., because they all contain the same items. That's what matters. But it's different from, instance, ACD, because even though there is an intersection, it's not entirely the same combination of 3 items, right? So that's the general idea. These are combinations based on a, oops, what was that? Based on some inventory set, right? Or working set, or a sample space. Now, from every single combination in turn, we can form the permutations, right? And this is, as I already mentioned, like for 3 items, 3 factorial, meaning 6 different orderings. So this gives us 20 times 6. That's 120 different orderings we can construct from those, based on those 6 original labels, A, B, C, D, etc., etc., etc. Now we don't have to go too deep into the mathematics, but I hope the 2 notions, permutation and combination, is clarified so far, because now we are, of course, interested in category labels. Now, that depends on your annotation scheme or on your database. Let's say we have a set of, the category labels. And now what our procedure does is we take that set, we generate all combinations, let's say of size 3, and then create the permutations of all those combinations, and then we browse the database and check what is attested, what is not attested. And then, okay, let's actually skip that for a moment. We will get a list of successes, let's call it that way. And you can print out every single success, and it will give us, for instance, this kinds of information, like what is the combination, right? In this case, it's adjective, noun, possessive. The score, 5 out of 6, and how many altogether. And then, of course, this is what we already know, like which concrete permutations are attested, which ones are not attested. Well, one option is, instead of Boolean, you can, of course, also give you the actual number of attestations. This can also be very convenient, very useful. Then, of course, the idea is that you can get this for all successes, right? You have a list of, if for a particular combination you do have certain hits, then it will be counted and stored in that list, and then you can check, right? And here is a brief illustration for the Overslandic database. In some cases, it may not be very exciting, because we know in advance that relative clauses, for instance, are always the final component of a noun phrase, so that's not too exciting. On the other hand, it may be very exciting to see that we even have combinations where we get 6 out of 6, right? As a syntactician, this should be very interesting. But the crucial thing is, our, this example with the perfect friendship, this was an accidental finding. It was a lucky accident. The method I developed is totally systematic and exhaustive. If there is anything like that in your database, you will find it, right? And it provides you also the score, the corresponding score, right? So this is, I think this is really, really very cool. Now let's actually skip. There are many, many more things you can do. Finally, I would like to show you one final thing. And this has to do, this is very abstract, the counting. This is, I squeezed all the patterns that we had. In this case, this is the prenominal space, right? Chopped off the rest. And then counted in which slots, in which position does which category occur how often, right? This is not a very linguistic procedure. It's just a counting thing. And then you can, if you have the numbers, you can say, well, the probability that, let's say, a demonstrative occurs in column 2 is so-and-so high, or an adjective occurs in the column 3 is so-and-so high. And as you can see, there are only very few categories that occur in the last prenominal position. That means those are categories that tend to be followed by a lot of other categories, namely adjectives. Conversely, if you start counting from the final position, then you will see there are only very few categories that can precede other categories, right? Here, for instance, demonstratives and quantifiers. Now, with some mathematical magic, you can calculate a value for every category that gives you a very abstract value, namely the distance from the noun. Right? So this is not a syntactic measurement, it's really a very probabilistic thing, and obviously demonstratives have a higher score than adjectives, and everything is somewhere in between. And then you can use it to visualize actually the noun phrase. And what I've done here is actually you take the score of each category on the x-axis, here in this case this would be the negative x-axis, and the number of occurrences, the raw frequency, on the y-axis, right? So these are the category labels, and this is the prenominal space. This is how they are distributed. The arrows, you can do lots of things. I use them to indicate precedence relations. Red means always precedes. Green means precedes in 75% of the cases, but maybe other. And blue means, well, less than 10 attestations, right? You can do many, many more things. This is just one example of what you can do. And this is Old Icelandic. No matter what exactly this graph or this diagram tells us, this is Old Icelandic, and it looks a bit different from Old Saxon, and it looks a bit different from Old Icelandic. So if you have a sufficiently large database, you can actually visualize, in this case, the noun phrase, right? It gives you a fingerprint of a particular language, or at least of a particular collection of texts that you have in the data. And maybe if you have enough textual material, you can also use it to identify different authors. I don't know, But this is the direction where this is going. Now, well, it's been half an hour. I'm pretty much done, actually, with the content. I can, as a brief summary, what I've been talking about, patterns, combinations, permutations to check combinatorial flexibility, and of course also use it to visualize noun phrases and distribution of categories in the probabilistic space, so to speak. Now, patternization, this was my Hello World program, right? My very first program, so it's not totally super, it's not very efficient, and especially combinations by their very nature, they take a lot of computational power. So I'm currently developing the new version, which is also a bit more flexible, because this version is tailor-made for our own database and our own annotation scheme, but I would like to make it a bit more flexible, so we can also use other existing corpora to do what I've been showing you to those corpora. That's pretty much it for the moment, so thank you very much, and I'm looking forward to your questions.
Oh, thank you.
Thanks.
Yeah, so you have a question to us, actually. But first, any questions? So I have one actually on the, maybe a bit to the point of your talk. So could you extend this approach to model cross-linguistic variation in word order that is in the left periphery?
Yes.
How would you go about it?
Now, who would ask such a thing? Well, obviously that's the idea. Now, of course, I've been talking about noun phrases on the one hand because I've been looking at noun phrases for my entire academic life. And also the project was about noun phrases, but okay, maybe I should have mentioned this. The idea is, of course, you can look at any constituent, right? I mean, anything that you have can define, every domain you can define, you can do the same procedures. In fact, maybe I should mention this before. Here, now these are in fact proper noun phrases and they are constituents, right? Those are noun phrases as noun phrases go. But what I did here, actually here, prenominal and postnominal. Now the prenominal field and the postnominal fields, those are not constituents, right? Those are segments of the noun phrase, but I've done the same thing to actually those segments. You know, you don't even have to have a constituent. You can do it to any domain that is somehow structurally defined, right? Including the left periphery or what other, you know, the middle field, the pre-field, those kind of things. And of course, all kinds of constituents. That's the idea.
Yeah. Thank you. So can I ask you, you're comparing Old Icelandic to other linguistic databases. So what precisely is the database for Old Icelandic?
What the database is?
Yes. So what kind of is the concrete database that you're working with?
Now let's.
As a non-expert in the field.
I mean, this is like, as I said, this is. NPEG. This is like a link to it. The NPEG. This is our own database that we created from existing corpora, from ISPEC for Icelandic and for you know for I don't remember all the. I don't remember which one we used for Old English and Old Saxon, but we used existing corpora and created our very own database, the NPEG. And here's the link. You can actually check it out for yourself. So this is what what the numbers and the examples where these are from. Yes?
It's a more linguistic question. You said that Icelandic has 5 of the 6 patterns that are possible.
Yes.
Why do you think you can't have the 6th?
I see. Here. Now actually let's have a look.
We need to look at the 6th.
So the thing is, okay, maybe I should have mentioned that as well. In historical linguistics and corpus linguistics, non-attestation does not necessarily entail that something is ungrammatical or doesn't exist. Just it doesn't exist in your database. It could be extremely rare. There may be all sorts of explanations. Now in this particular case, noun, adjective, possessive is not attested. Maybe, okay, this is, looks like, okay, there could be a reason for it. Like in terms of you know, how you, first of all, what the base structure is and how you could move items around. I haven't actually thought about it in this case because
I'm just thinking about your last slide where you had this, where you showed pre-field and the post-field.
Yes.
Is it more likely that nothing can follow, that the possessive has to be, because it's in...
I mean, okay, that would be in post-nominal position.
Yeah.
There is actually one interesting thing which is very cool actually, but I don't have it on the slides, but maybe I explain it a bit. Demonstratives. I was looking at demonstratives in the post-nominal field, and there are tons of like mother, sow, like man, that, you know, like tons of those kind of examples in the Old Icelandic, and there, of course, noun demonstrative. Some other stuff follows as well. Not a problem, we found plenty of it. Now, if you look at patterns, and this would actually be where I have my search templates. These are meta templates. If you browse the database, this is what you're looking for, and this is what you would get. There is the option that you can actually align the pattern, right? You know, like left aligned or right aligned. And I was looking at cases, noun, X, like any category, and then demonstrative. First of all, when the demonstrative is final, and I have 0 attestations, okay? So which seems to suggest, well, post-nominally a demonstrative cannot follow other categories unless there is a relative clause following the demonstrative. And in that case, I was testing actually the idea whether demonstratives in Old Icelandic could be used as relative pronouns, right? This is an idea that is widespread, and that is confirmed. What you were asking is, can we do something similar for the possessives, right? Which I haven't done, but that would be the idea.
Mm-hmm. Yes. Maybe to your question about the relevance of this to digital humanities. That's kind of what you raised there at the end.
Yes.
Yeah. I mean, humanities obviously includes linguistics, several languages, but in kind of digital humanities, I think we have there is a kind of a separation of fields, also seen in the European area, where you have Clarin as a kind of an European infrastructure for linguistic data, and then you have DARE and all sorts of things for the rest. And in linguistics, you've been doing this sort of things for a long time, kind of turned more scientific than a lot of the rest of humanities. But what among the things that we want to do and promote is kind of pattern recognition, etc., in other kinds of data, where we have the data. Obviously, we don't always have the data that you have now in the linguistics. It's been kind of developing this for many years.
Yes.
So I think there's a kind of a clear relevance for kind of all sorts of digital humanities when it comes to this type of methodology.
I'm very glad. Well, actually, one thing I think I didn't make that perfectly clear, that I personally think is, of course, to all of you, like learn Python, learn programming, right? There are, of course, already, there are for all sorts of fields, there is already existing software and gadgets that you use if you work in the digital humanities. But in a number of cases, it's always helpful if you know the basics. Python is a very approachable language, and you may have, problems or questions that are very specific to your own task, right? And you cannot always wait until somebody else invents it or creates it, right? And there are things that you can actually do with a simple programming. That's actually my message, right? I don't know exactly in the all non-linguistic fields of digital humanities what kind of tasks you have, but it's always helpful, and you will find your own creative solutions if you know some, programming.
Yeah, I think that's kind of one of the differences we have between kind of areas of digital humanities, that we don't all know Python.
Well, that's why I'm here.
Or we don't all learn it. But if you go into this in linguistics, you just have to do it, and you have to know about data.
Well, I know tons of linguists who don't know Python, actually. So, but it's my personal experience. So, I started, it was first playing around with our own database, and then actually I got into it. So, it's really cool. And the kind of things I could do, sometimes. I think it was more the playing around than the actual linguistic benefit, but nonetheless, eventually I think it's paid off, and it's very helpful.
Yeah.
And as I said, this is very obviously linguistically oriented, but I guess for all of you, you will find your own creative approaches once you understand how to use it.
Yeah, absolutely. So, if there are no more questions, thank you again for a great presentation. And
thank you very much.
Thank you. See you.